going to start talking about 2.7, which is combining functions. So addition, subtraction, multiplication, division, and also composition of functions, along with their domain. Okay? So let's start. All right. Okay, so 2.7. So 2.7, combining, oh, it's not what, oh. So 2.7 is combining functions. It's okay now? Yeah. Alright. So the sum, the differences, products, and quotient. So A, sum, differences, product, and quotient. And quotient. Okay. Suppose. So let F have domain A and G has domain or have domain B. Then this is the sum. Well, sum is what? Plus? So F plus G of X is equal to F of X plus G of X. And the domain is a intersection B. Yeah. So early in the beginning of the course, we talked about intersection, what intersection means. Okay. Now, difference. What do you think I will write for difference? Yeah, that's right. So F minus G of X is F of X minus G of X, and the domain is still A intersection B. Yeah. And the product, well, you know what product is, right? Product is F times G of X, which is F of X times G of X, and same thing. The domain is A intersection B. Now the last one is the quotient, which is F over G of X is equal to F of X over G of X. Well, what do you think the domain would be? It's also A intersection B, but what? G cannot equal to 0, yes. So X in element of A intersection B such that G of X is not equal to 0, yeah? So the denominator cannot equal to 0. Are we okay so far? Okay, let's do an example. Yeah. So, for example, let F of X be 2 over X minus 3, and G of X be square root of X. You guys should get flu shot. For sure, right? I mean, it's just really bad. It's just really bad. Yeah. Did you guys get flu shot? When will the flu center have it? Sorry. Okay. Okay, so let me just write it, okay? So find plus g times minus g times g and their domain. Alright. Alright. So B oh sorry, also F over G. B find F plus G of -4, F minus G of -4. That's it. Yeah. Alright, let me go to reading. Okay. Did you guys work on it? Yeah? Okay. So A, what is F plus G of X? Two over, let's write it separately first. So this is F of X plus G of X. So F of X is 2 over X minus 3 plus G of X is square root of X. So can we combine this? Not really. So we could just leave it the way it is, right? Yeah, so you can't really combine these. Leave it the way it is. Now what about the minus? Same thing, right? So you can do the minus, can't you? What about the F times G? Same thing. So F times G of X is equal to F of X times G of X. So this is 2 over X minus 3 times square root of X. So it's just 2 square root of X over X minus 3. Alright. How about the last one? Oh, this is still A. I didn't have to label this. What about F over G of X? So this is F of X over G of X. So 2 over X minus 3 and then what? Divided by square root of X. So what happens? What am I going to do next? Multiply by the reciprocal? Yes. So this is 2 over X minus 3 times 1 over square root of X. So this is 2 over square root of X times X minus 3. Yes? Okay. Now, Let's talk about the domain. Do I sound funny? I'm sorry. Yeah, I can't help it, you know. Yeah. I went to specialists and things like that, but they didn't give me anything. So. They... What happened? Oh, what is it called? Oh, okay. Thank you. Yeah. I use this one is recall. Okay. Yeah. Let us write it down. Thank you very much. Oh, okay. Okay. It has been a few days. And last week, you write it down? Okay. So hopefully tomorrow my voice is clear. And I don't have that much. Thank you. I usually don't get sick. I don't know why. So you get this at CBS? Okay. Thank you. All right. So now let's talk about the domain. What about the domain of F? What is the domain of F? So what is the domain of F? So I'm going to write down, so domain of F, which is A, so we will call it A, okay, because it makes it easier. So all real number except for, okay, so how do I write that? Negative infinity to infinity, and then when I draw it, what happens? You have an open circle at? Okay, so is this clear so far? So that's the domain of F, right? It's all real numbers except for 3. That's why we have an open circle at 3. Now, what about domain of G, which we call B?
Do you want us to graph it, or do you want us to write it in interval notation?
Oh, not yet, because what they were asking for was the domain of F plus G, F minus G, F times G. So look at these. These 3, look at this. They have the same answers, right? So this is 3 different questions. What is the domain of F plus G, F minus G, F times G? This is 3 different questions, but the same answer. Yeah. So let's talk about these first. Domain of A, F, and domain of G. So what I need to find is the domain of F plus G, F minus G, F times G, and F over G. What is the domain of B? Greater than 0? Okay, so how do I graph it? 0, open or close? Does it include 0? Can I have square root of 0? Yes, yes. So it is 0. Now, can I clarify these, or you guys are okay? So if you have square root of anything here, what happened to this radicand? This thing must be greater than or equal to 0, right? So yes, it includes the 0. All right. Now, this is not answering the questions yet. What we are given here is what is it? Domain of F and domain of G. So A and B. Now, what do you have to find? Yes, the domain when they're added, subtracted, or multiplied. So we're looking for A intersection B. So look at the graph. What is A intersection B? What does intersection mean? We talked about it really in the beginning. The first day I came here. Huh? When it's what? Yeah. Well, 2 lines. So this one, the lines, for the first one, the line goes here, right? It has an open, well, I didn't draw it correctly. It's everything except for the points. Okay. So which points have 2 lines on top? Where? Where 4? There's no 4 here. Okay, so if I combine these together, how does it look? Okay, so maybe I have to lower this down a little bit. So if I want, if I draw this number line together, so this is 0, all right? And what else do I have? 3. Okay, and it's open, meaning to the right of 3, to the left of 3, but not exactly at 3. Now, this is A intersection B. This is, the keyword is and, right? So, it has to have 2 lines on top. So, which points have 2 lines on top? 0 to 3, union, 3 to infinity. Yes. So let's write that down. So A intersection B is 0 to 3, union, 3 to infinity. So this is the domain of F plus G. Yeah, so three questions. So this is the domain of F plus G, F minus G, F times G, which is equal to 0 to 3, union, 3 to infinity. Can I clarify anything? I know this is still a little bit hard for people.
How you getting 0?
How do I get 0? Okay, look at this. What is the definition of domain? The set of all possible inputs. So what can I put here? No. What about if I put -1? You can. Not only positive, but what? Also 0. So if you have a square root, if you want to find a domain, you have to set whatever it is greater than or equal to 0. So that is the domain of this function. The radicand must be greater than or equal to 0. Okay? So suppose if I ask you, what is this domain of this function? F of x is square root of x plus half. What is the domain of this function? So how do we find the domain? X plus half is greater than or equal to 0. So x greater than or equal to -half. So the domain is -half to, yeah. You see? That's how we find the domain if we have a square root. Yeah. We didn't talk about this? The first day, right? Okay. Let's see. Anyway, but any other questions? No? All right. Now, how do you answer the domain? So we answered 3 questions, which is the domain of F plus G, F minus G, F times G. What is missing? Okay, F over G. How do you answer that question? What is the domain of F over G? So this is a digression. Yeah. Okay. So this part right here is not our problem. All right. So how do you find the domain of F over G? So domain of F over G, what? Gx cannot be 0. Okay. So what would that be? So it's the same answer, but the Gx cannot be 0. Yes. So is A square root of B excluding x where g of x is 0. So which one do you exclude? So which one do I exclude? Do you guys get it or not? 0? Yeah. So square root of x is 0. So x is equal to 0. This is the one we have to exclude. Okay. So So what is your answer then? So domain of f over g is what? 0 to 3 union 3 to infinity. Yeah. Yeah, because this is yours. This is your answer, but you have to exclude when x equals 0. So you're not excluding this point only. So that's why I have 0 to 3 union 3 to infinity. Does that make sense or no? You want to do one more? Okay. So just find the domain, okay? Because I know you know how to do the f plus g, f minus g, those things. Okay. Let's see. All right. Okay. So next question. So this is number 1. Let me label this. All right. Oh, B. Can we do B? Can you do B? Very simple, right? Okay. We didn't do B yet. Maybe I'll do it here. Let me see. So B. What is f plus g of negative 4? So this is f of negative 4 plus g of negative 4. Yeah. What is f of negative 4? Oh, it doesn't exist, right? Oh, okay. So I have to change it to positive 4. Yes. Sorry. Because otherwise it's not on the domain. You can't really add. Right? Yeah. Square root of negative 4 is imaginary. Yeah, you're right. So what is f of 4? 2 over 4 minus 1 plus square root of 4. So this is equal to 4 minus 3. What am I doing? Yeah. Okay, so what is this equal to? 4? Yes. What about f plus g of negative 4? Of positive 4? F of 4 minus g of 4, 0, right? So 2 over 4 minus 3 minus square root of 4. So this is equal to 0. Yes? Okay. All right. Yes? So far so good? Okay, so let's just find the domain. Yeah, you guys ready? So number 2. All right, so number 2. Just find the domain. Find the domain of the function for each function. Okay. Number 1. So A. F of x is equal to square root of x plus square root of 1 minus x. Okay. B h of x is equal to square root of x plus 3 over x minus 1. Okay. So tell me what is A and what is B. So how do you find A? So square root of x is greater than or equal to 0. So x must be greater than or equal to 0. That's your A. Right? Okay. How about your B? Yes. So 1 minus x is greater than or equal to 0. So negative x is greater than or equal to negative 1. So x is less than 1. Yes. So then you could grab these, and this is an N because you want A intersection B. A intersection B is N, and you need 2 lines. Right? So A intersection B. So 0, and my arrow points to the right. Yes. 1, my arrow points to the, okay. So I was telling my other classes, when they draw the arrow, don't draw like short. It has to go all the way through the number line. So if you're like this, if you draw your arrows like this, then you can't really see. Right? So when you draw the arrows, draw it all the way to the end of the number line. Like this. So it doesn't stop in the middle. Does that make sense? Yeah, because if you stop in the middle, short arrows, you can't really see. Now, so which one is N? So this is N. What does N mean? No, 2 lines. Not at least. It's exactly 2 lines. So which points have 2 lines on top? Between 0 and 1. Okay. So what is the domain then? Bracket 0, comma 1. Yes. All right. Okay. Now, can you do B? And then let me give you C, and then I will give you back your test and your stuff. So g of x is equal to square root of x plus 1 minus 1 over x. So can you guys work on it? Tell me what the domain of each function. Oh, you also have a table, right? I did it in more detail. Okay. So please work on it while I will do the practice. Okay, so there are 4 things that I was going to give back to you. One is the test. One is the portfolio. And there are 2 things. Okay. So many, right? All right, so Renee, okay, you turn them all in. Maybe we should have this. Sophia? Yes. Jasmine? And this is alphabetical order by last name. Listen to Melissa? Oh, anyway, let's start again. Share desktop, share. All right. Okay. So, Brian. follow up in this course. Okay. So anyway, the first class is a take home and it's a review. I would expect it to be 80% or higher. Yeah. But if it's a little bit less, it's okay. But it's just like okay. So please follow up. If you don't follow up, so I'm not like high school kids. I'm chasing you around. No. Yeah, you have to be grown up, be an adult, and then come to me. Alright. Now, let's talk about B. So, are you done with B? Okay, so what do we do here with B? What is A? X plus 3 is greater than or equal to 0. So X must be greater than or equal to negative 3. Good. What is B? What is the domain of the denominator? What is the domain of X minus 1? No, right? B is, what is the domain of X minus 1? If you have this function, X minus 1, it's just all real numbers, right? Okay. So, and then we have to exclude the denominator. Alright. So the domain of X minus 1, f of X equals X minus 1 is all real number. But then we have to exclude what? One more. Exclude X equals 1, right? Okay, so tell me how I would draw it. X is greater than or equal to negative 3. So negative 3 is close and to the right. Okay, good. All right. Now, I need all real numbers. So this is all real number. What is A intersection B? This is your A. This is your B. What is the intersection? Which one? Which one is the intersection? Which one? Huh? Oh, not yet. And then I have to exclude the denominator when the denominator equals to 0. Yes. So here, negative 3 to infinity. Right. But then I have to exclude, so domain of h of x is negative 3 to infinity, but I have to what? Excluding 1. Alright, so that's what it is. So A intersection B is negative 3 to infinity, but then for the whole function itself, you have to exclude when the denominator equal to 0. So how do I exclude 1 from here? Negative 3 to 1, union 1 to infinity. Yes, that's right. Yeah. Okay.
What does the number mean? If it's all real numbers, doesn't it be negative infinity to negative 3 union?
Okay, it's an intersection. So what does intersection mean? It needs 2 lines on top. So which points have 2 lines on top? See here, this is one line and this is another line. So if you're saying, so Alex here, if you're saying negative infinity to negative 3, look at this. How many lines is between negative infinity to negative 3? It's only this line. But I'm looking for points which have 2 lines on top. So it's this point. So these points, okay, it has 2 lines on top. Make sense?
Yeah.
Okay. Good. How about C? Alright. So, what is A? Oh, okay, what is it? X plus 1 is greater than or equal to 0, so x is greater than or equal to -1. Yes. What is B? X cannot be 0. X such that x cannot be 0. Alright. Right? Okay. So what is A intersection B? So let's graph it. -1, open or close? Close, and the arrow points to the right. B, x cannot be equal to 0, so open. And then I have these two lines, right? Oh my god, okay. Anyway, which one is A intersection B? Okay. Yes. -1 to 0. Union 0 to infinity. Yes. Okay. Is this okay for everybody? Yes? Okay. Good. So next, let's talk about composition of functions. Yeah. Questions? Why is look at this. Why is A intersection B in part B and A intersection B in part C is different? Do you see how I treat this differently? Why is B here? What is the domain of x minus 1? Is all real number. Why can't I just say, oh, it's all real number except for 1? Because this is a quotient. So you're thinking about this is a function and this is another function, right? And then you have to find the domain of the first function, the domain of the second function, okay? And then you have to exclude where the bottom is equal to 0, right? Now what about this? So I'm thinking of this as the first function, and which one's the second function? This one. Yeah, that's why I treat it differently. So here, that's why I have excluding 1. Here, I don't have excluding 0. It's part of B. Yeah. So I excluded 0 when I was doing B, when I was working on B, instead of finding the intersection and then excluding it from the intersection. Does that make sense? Okay. Now, the next one, B, is composition of functions. So B is composition of functions. Okay. All right. I think you've heard this. This is F circle G. So if we have F circle G of X, this is F of G of X. So have you seen this before? Yes. So what is F circle G? F circle G, this is the composition of F and G. Yeah. And this is called a nested function. Nested function. Okay. So the G is inside the F. So that's called a nested function. Yeah. Which one is inside? Which one do we apply first? G, the closest one to X. So G, the closest one to X, the function closest to X, is applied first. All right. Okay. Now, let's see. Okay. So, for example, let's do an example. Suppose f of x is equal to x cubed and g of x is equal to x plus 2. Okay. Okay. Find f circle g of x. So A, find f circle g of x, and B, find g circle f of x. All right. So, how do we do it? Answer A. F circle g of x is f of g of x. Okay. So, which one do we apply first to x? G. So, f of x plus 2. All right. So, what is f of x plus 2? Yes. All right. So, what is x plus 2 cubed? So, you can do it on the side and then put the answers here. Okay. Or you can write it here. X plus 2 times x plus 2 squared. So, times x plus 2. All right. So let's multiply these first. What is x plus 2 squared? Plus 4x plus 4 times x plus 2. All right. Then what? X times. So I'm going to distribute the shorter one. So x and multiply by the first polynomial plus 2 times the first polynomial, x squared plus 4x plus 4 plus 2 times x squared plus 4x plus 4. So what do we have here? You can, if you remember. Yeah, you can use special product if you remember. Yeah. So what would this be? X cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Yes. So this is x cubed plus 6x squared plus 12. Is it 12x? Yes. Plus 8. Yes. Okay. So yeah, you can use special product. So 1, 3, 3, 1, the coefficient, those things, yeah, you could use that. Yeah. Good. Now, what about G circle f of x? So write it as nested function first. So this will be G of f of x. Yes. All right. So this is G of x cubed. So what is G of x cubed? What is G of x cubed? All right. So what is your conclusion? Are they the same? No. So yes. So in general, F circle G is not equal to G circle F. That's in general. Yeah. All right. So you could also compose three functions. Do you want to do three? Yes. Okay. And then you could recognize. So let's do compose three functions. Let's do simple ones then. Okay. All right. So number 2. Are you ready with this? Okay. So number 2. What about if you have to find circle G, circle H is f of x is x over x plus 1. G of x is x to the 5th, and h of x is x minus 3. Okay. All right. This is not hard also. So f circle G circle H of x is, how do I write it as nested function? F of G of H of x. Oh gosh, yes. Okay, good. Then what is this? So this is f of G, and then what is H of x? X minus 3. Okay. All right. Now, what is G of x minus 3? So f of, what is G of x minus 3? So this is what I evaluate. H of x is x minus 3, right? Now, the next one is, what is G of x minus 3? So I don't evaluate f yet, so I'm leaving my f outside. So what is G of x minus 3? X minus 3 to the 5th. Yes, good. Now, what is f of x minus 3 to the 5th? Come on, guys. What is it? X minus 3 to the 5th on top, divided by x minus 3 to the 5th plus 1. Yes. Done. Yeah. So you don't have to distribute this. Yeah. X minus 3 to the 5th divided by x minus 3 to the 5th plus 1. Are we okay so far? Okay, good. Now, the other thing is recognizing a composition of functions. So, recognizing a composition of functions. So I'm almost done. After this, I'm done. So given f of x is equal to, let's just say, 3x squared plus 2, find f and g, or find f and g, so that f of x, so that f is equal to f circle g. So what type of operations do we have? Yeah. So you have to decompose. Instead of making a composition, you have to decompose here. Alright, so not making composition, but you are decomposing. Okay, so what should we do here? Now let's start with x. There are a few operations that I do to my x. What do I do here? Square it. Okay, then you get x squared, and then what do? Multiply by 3. Okay, good. And then add 2. All right. Yeah. So there are actually 3 operations. So you start with x, you square it, and then you multiply by 3, and then add 2 to it. Yeah. So now, if you have to decompose it into 2 different functions, then we could just either combine this with this, and then at last we square. Yeah. Okay. So square. What do we do? So which one do we do first? We square first. So this is your g. So g of x would be x squared, because that's the function in which you square. Now, what about f of x? What is it? 3x plus 2. Yes. Is this the only option? No. So you could decompose it like this. The square and multiply by 3. And then you add 2. So this is your g. What is your g then? Gx is 3x squared. So x squared and then multiply by 3. What about your f? Yes. So you have 2 options. Yeah. So you could check if this is my f and g. What is f circle g here? So you should get 3x squared plus 2. And what is my f circle g here? Then you should get 3x squared plus 2 also. Yeah. Okay, good. So I'm actually done with 2.7. I have a long office hours today. It is 1:20 until 3:30 in my office. So if anybody wants to come and ask questions, you guys can come. Yeah? Okay. All right, so I will see you tomorrow. Yes, Jennifer. It's 1:20 or 1:30? I can't remember. Till 3:30 in D5 111N. Yeah? Okay. Good. Yeah.
Should I write domains for this question?
Denominator.
Denominator?
Yeah, when you're adding something, it's like 2 rational expressions. You have to carry the denominator, right?
Okay.
Yeah, so your LCD is x times x plus 5.
Okay.
So
I
when you
just skipped that.
yeah, so it has to have something on the bottom.
Okay.
So the bottom will be x times x plus 5.
Yeah. Oh,
Yeah?
yeah. Right.
Yeah.
Thank you.
You're welcome. Oh, I don't need this 0953. Okay, you're good. Okay, see you tomorrow. All right, so we're done with 2.7.